what happens here real fast, guys, when you have the ones like 25, where you start to divide stuff. When you divide stuff out, you have to think about the multiple ways that you can use division with polynomials. There's 3 different ways you can go about it. One of the ways is to factor the numerator to see what simplifies. The other way is to use long division. And the third way is to use synthetic division. In this case, it's always easier to see if you can divide synthetically because it's quicker. Okay? So here, when I wanted to use synthetic division to simplify this mess out, I divide by the 0 of the denominator. What's the 0 of x minus 1? 1. So I throw a 1 in here, and I'm dividing it out. And I have a 2, 1, and a negative 3. Drop the 2, multiply, add, which means when I divide by x minus 1, what am I left with? I'm left with 2x plus 3. That would be the answer here. But now, taking it one little step further, because we did not talk about this yesterday. We didn't talk about what's called domain. Do you guys remember back from Algebra 1 or some other random Tuesday of your lives that you might have talked about domain and range? Domain and range were think of it as all your possible x values and all of your possible y values. Do you remember which goes with which? Why is it domain with x and range with y? That's it. It's the easiest way to remember that. Domain comes before range in the alphabet. X comes before y. It's the easiest, dumbest way in the world to remember these things.
Wow.
I know.
But why is it like
Shut up. So, what I'm looking at here, when we start talking about domains, you're looking at most of these problems, your domain is going to be all real numbers. Some of the problems, you're going to have restriction upon your domain. Domain restrictions usually occur when you have something that you divide by 0. In number 25, we have a domain restriction. Because what can't x be in the denominator? 1. So my domain, if I start going into this further here, my domain values for this problem, my domain would be all real. Well, it would just say x can't equal 1. Because if x equals 1, I'm divided by 0, black hole of death. Can't do that. I know, it's fun, but you don't want to. All right? So that's why we start talking a little bit more about domains. We'll start to talk more and more about that because as we get into inverse functions, probably now not until Monday, which is fine, that there's reasons why we worry about inverse functions in terms of relationships between domains and ranges. They flip-flop each other, okay? And that's where that stuff comes from. Now, if I look at 26, 26 is the opposite. 26 is taking this problem and dividing it the other direction. Thank you. You're here all week. 26 has you doing this. I could. I wonder if I could do it this way. Whatever. It's like Arabic almost. It looks kind of cool. All right. So in this case, you really can't simplify anything out right away. But remember, the problem before, you just divided out by the 1, which meant that this denominator is the same thing as x minus 1, and what was it, 2x plus 3, I believe? So now if I think of this, I could simplify it. Is this wearing a flotation device? No. So the answer would be 2x plus 3, but go back to the original problem. What was the domain restriction of the original denominator? You couldn't have x equal to 1 or 3 halves. So your domain for this problem would have been x not equal to, this stands for all x not equal to 1, or negative 3 halves. Your domains, you're basically going to be plucking out the values that it cannot be. Otherwise, it's if you say, like the other problems there, like 21, 22, where you're adding or you're subtracting and all that, none of those values are going to give you an undefined setup. So you just say domain is all real. Things like that. Okay. The domain and range and finding zeros become into more importance as we get into second semester when we start talking about rational functions. And it's basically, we're going to take this type of a function and graph it. And it's very simple to do because all you do is you plot their asymptotes and draw a couple of curves. And those things are all about the... Why, hello, bonjour, hola, ¿cómo está usted?
Disculpa la interrupción, señor. Pero necesito, no, necesito hablar con
Yes, you need to talk with Grace.
Federici. ¿Está
Oh.
Grace? Hola, Grace.
Tú tienes drogas en su locker.
No.
Drogas.
Gummy bears, please.
Yeah, don't eat gummy bears.
That was at my dad's work.
So, are we okay with this?
Yeah.
No, I'm going to add to it. Because we have another part of this. We did all this yesterday. So what I want to do here real quick is show you another example of how you talk about domain and range when it gets into stuff that has a little bit more work to it. No, save it. You're just going to add it. I got another couple problems to add to it tonight. So, in this example here, I want to just show you guys the adding and subtracting portion and talk, or actually I'm probably just going to do the adding portion because subtraction is the same thing. La puerta. Adios! So, what I want to do here real quick is show you guys the addition portion of this and then show how it works in relationship to domain. Remember, what I'm looking at here a lot of times for domain is what can't x be. It's easier to write down the restriction than it is to list them all. So this says, what is f plus g? Well, write down the f equation and add 3x plus x to it. And now you are at a combined like term problem. What's 4x and x? 5x. People were asking me this earlier today. What's the proper etiquette to write down the order for these things? Descending order is the proper etiquette. The one thing that I would suggest though, since this radical has nothing else underneath it, sometimes people when they write it down, they accidentally extend it with the 7 underneath here. So if you have that, is it the end of the world if you wrote 5x plus 7 plus the square root of x? So that way you don't accidentally extend the radical? It's okay. All right, it's okay. It means the same thing to me. Personally, I probably would have written it like the last one. That way I don't accidentally overextend the radical. So now think about domain in this case. What does x have to be to make this work? What can't x be? Yes, sir. Can't be negative. X can't be negative. Okay. Can it equal 0? Yeah. So it has to be all non-negative numbers. So how would you write that? Well, x is greater than or equal to 0. It can equal 0, because what's the square root of 0? 0. So let's try this again. What's the square root of 0? 0. Now, all that means is that you can't have any negative numbers. What happens if it said underneath the radical, what if it was x plus 7? What would x have to be greater than? Not 7. Negative 7. because you want to figure out what's the last barrier for that before it becomes negative. So some of these things, it might just take a second to think about, what can x be to make it work? Hi, long toss!
Can I borrow a closet key?
I gotta find one.
Oh.
Hold on, I don't have my keys. They're over here somewhere on my book. Domains!
Domains. The domain is always all real numbers.
Except when there's a radical in it. It's not one of those. Alright. So let's talk about Hannah being player of the year.
Woo!
Guys, this is pretty awesome. Applause. What's that? We're going to talk about the composite stuff. Composite stuff is the last little bit of what we're going to be able to get through today. It's another way of taking two functions and building them together. And it looks a lot like...
You're so cute.
Shucks. Thanks. I got to get a haircut though. Notice I didn't superimpose your face on anything? Yet?
Because you have to do it when we're watching.
This was really cool. That was very cool how I did that shot. I thought about putting her face on the floor, but I thought that might be a little weird. Player of the year in volleyball.
Nice. You win.
That's a bad high five. I think you do better than that. Jeez. All right. Composite functions. This is that, you might have seen it in the homework prompts a little bit yesterday where you had, we had stuff that looked like this, f times g of x. And then on one of the other ones it might have said, you might have saw that. Was it an open circle?
No.
Well, I'm going to try to shed some light on this foggy situation.
No.
No.
Stop reading
No, yeah. Thursday, December 7th. Remember to do this joke.
It's the 8th annual.
Why
are you
You just broke our teacher.
Alright, so, yeah. So this is actually really, really simple to set up. It just, like I was telling in the second hour, it's the way that things are written, it takes a second or two to understand what they're actually asking you to do. When we talk about this composite of functions, this stands for f of g of x. That's what that means. They normally write it a couple of different ways. You'll see it written with the fog or a golf, or you'll see it written like this, f of g of x. And to me, I think by seeing it written like this is a very easy way to interpret what in fact is going on. Now, the other day, when we first started talking about composite functions, I had this example. I think I wrote something down where it was, f of x is x plus 1, g of x is 2x minus 3. And let's say, what is f of 2? That means, which equation do you pick? F. What do you put in for x? 2. What's 2 plus 1? 3. Now, what a composite function would be is, what is g of f of 4? That means, go ahead.
You plug in the 4 for the x and the f function, and you put the f function in for x and g.
Done.
Wait, can you explain?
All right. What I would do here is, this is working order of operations. This says take 4, substitute in the x equation, or to the f equation, and you get 5. So that means then, what is g of 5?
7.
It's 7. That's all it means. It's telling you to do two things. Start with the innermost, substitute in, and build outward. And it means the exact same thing if it's just f of g of x. It means write down the g of x equation and surround it with the f equation. That's all that means. Because the g of x equation is playing the role of x. Okay? Just like this, we took the f of 4. I took the idea of writing down, putting the 4 into the original equation, into here, and then I surrounded it with the g equation, and I did the math. I did the exact same thing, but in this case, I'm keeping the value of x there. I'm combining the two functions into one. Simplify. That's all you do. Same idea if I go g of f of x. Move these down so we can see them. This means take the f equation, write it down. Surround it then with the g equation. The reason why I write the f equation down first is because it's closer to x. It's closer to it. So my f of x equation is 2x. That is now playing the role of the x in the g equation. So I just surround it with the g. Simplify.
Wait, so you're just plugging the F in for the GX?
That's it. That's it. What's that?
Where do you get a 3 from?
Where do I get the 3 from?
Yeah.
From the g of x equation. The g of x equation is 3x minus 4. The f of x equation was 2x.
Yeah.
Write down the f of x equation, 2x. This is now playing the role of the x here. That's it. That's all composite functions are. Putting one function in for x in the other. Or vice versa. Versa vice.
Actually, like that was funny.
Okay, same idea. F of x is x minus 5. Yes, ma'am. F of x is x minus 5. G of x is x squared. Wasn't bad for being left-handed there. They're Gonzalez cheese on the layer. Remember Speedy Gonzalez from Bugs? Yes.
Yeah.
Are you kidding me?
You have no child.
Wait. You've never seen like the buzzard in Bugs Bunny?
No, I've seen that.
No. You've never seen that cartoon?
No.
The Bugs Bunny and the buzzard?
I've seen like both.
That's like the best. Oh God. Oh,
playing
your poor
back to South
children.
Park.
Anyway, so basically what we have here is g of f of negative 3. Again, this just means take negative 3 and substitute into which equation first? Get an answer and substitute it where? That's it. You can do it one of two ways. Take the negative 3, substitute in. You get negative 8. Take negative 8, substitute in. Or substitute the whole thing. Negative 3 minus 5. There's your f equation. Then surround it with the g equation. You're going to get the same answer. Just do those lat stretches.
So do we just leave it like that, or do we have to like? do
Well,
all that
64.
stuff?
Yeah. I'm just showing that that's all. That's it's straight composite of putting something in for something else. It looks very weird, but the differences that you're going to see here is that you're going to have this open circle. The open circle just means composite, because there's an O in the word composite. And then the dot, the filled in one, is multiply, because the dot looks like multiply. No, I'm thinking of something to try to help you out here. Okay? So, I had, what did I give this second hour?
Page 402, 36.
Page 402, what was it?
36.
Now, these problems here are basic. They look exactly what you did yesterday, but they're throwing in a couple composite ones. Yeah, just add it to it, please. Yes, ma'am.
Do you want us to add the domain on the ones we did last night?
Throw the domain on these, we'll be fine. I mean, the other ones, I just showed you the 2 domains that actually had restriction. So, go ahead and do those. Go ahead and do those out for tonight. We obviously didn't get a chance to talk about the actual word problem version of this. The word problem of this one, I think I talked about this yesterday. Jane, you asked me about this, right? The coupon. And that's basically a lot of times where you see this stuff. When you have 2 different coupons, what do you apply first? And composite functions will show you with value which one is a better value.
Okay.
That's how you figure these things out.
Yeah. I just like don't forget how like you find that.
You know,
I
it's
understand the process, but like not like.
now when we start building it, you'll see it real quick. Because it's funny. My wife had, I'm such a nerd. We had 2 different coupons for pizza, and if you hit them in different, you could do one thing and do another. I'm like, oh, I can do it this way. She's like, oh god. I got all excited that I could do math for ordering pizza. Yeah, that's right.
So look,
So,
we do not get easy.
yeah, us dads, embarrass your children and order pizza. That's what we do.
So now when people ask what is math, I can just say
Pretty much.
and then people will guarantee.
See, like this is something that I like want to do because it actually applies to like